All right, so we're going to cover 3.5 and 3.6 today. In 3.5, we're going to be reviewing factoring. So hopefully a lot of this stuff looks familiar to you from another class. And if it doesn't, I'd say, make sure you spend some extra time on this because it's one of the most important skills that you're going to be learning this semester. So, all right, so getting into this, we're going to first talk about the greatest common factor. And basically the greatest common factor of two or more monomials is the largest of the common prime factors. So, biggest, or however you want to say it, I guess, but it's not wanting to write for me. All right, so it's the largest of their common prime factors. All right, so if we're trying to find the GCF of each of these monomials, we're looking to see the largest number, like if we're looking at the number part, the largest number that will divide in to both 6 and 4. And the largest number that will divide into that is 2. And then when we look at our x's, we got x to the third and x to the first, and we're always going to pick the variable with the smallest, exponent on it, because if we're saying it's common to both of them, this one has x times x times x, where this only has x. So what they have in common is just one of those x's. So 2x would be our greatest common factor here. Right? And then if we go down here to problem 3, where we're going to factor out the GCF now. So here I've got this 4-term polynomial, and I need to look and see what the largest number is that will divide into all of those. So I'm just going to look at the number part first. So that's 6, 14, negative 42, and negative 2. Now, if the leading coefficient is negative, we would factor that negative out with it. Otherwise, we're just looking for the number that divides into it, the largest number that would divide into it. And so in this one, it's going to be 2. And now we need to look at the x's. So let's go to that next. So I've got an x squared, I've got an x, I've got an x, and I've got another x squared. So again, like I said up here, you're going to be choosing the one with the smallest exponent on it. So we're going to be factoring out an x. So far I have 2x. But now I need to look at that y also. So this is y squared, y, and y squared. So a y is what's going to factor out here. So 2xy is going to be my greatest common factor. So basically when I'm taking a polynomial and I'm dividing it by a monomial, I'm really taking each of these terms and dividing them by that. So I'm going to rewrite this just so each part is being divided by 2xy. Right, and then when we do that, we can see, and these leftovers that I get here are going to go in parentheses next to it. So when I do the 6 divided by 2, that's going to give me 3. When I do an x squared divided by x, that's just going to give me an x. When I have a y divided by a y, that just makes a 1. So that divides out completely. All right, so that's what I have left, is just 3x in that first term. In my second term, I have a 14 divided by 2, which is going to be positive 7. Oops, that plus sign kind of looks like a T, but and then x divided by x divides out completely, so there's no x's left. And then with the y's, y squared divided by y leaves us a y. So I've got plus 7y on that part. The next term, negative 42 divided by 2 is going to give me negative 21. My x's divide out completely, and my y's divide out completely, right? X divided by x is 1, y divided by y is 1. And so I'm just left with that 21 there. Okay. One looks a little bit strange. All right, and then on the last term, again, we can kind of see negative 2 divided by 2 is going to give me a negative 1. And then with my x's, I've got an x squared divided by an x, so that's going to leave me an x. And a y squared divided by a y is going to leave me a y. And so we're using these properties of exponents that we talked about before to be able to figure this out, because when I'm doing a y squared divided by a y to the first, really I'm doing that 2 minus 1, right, because it's connected by division. Right, and so that whole thing together, right, all of this together is the factorization of it. So 2xy times 3x plus 7xy minus 21 minus 1xy. And that 1 you don't have to put, you could have just put it as minus xy. Okay? So on this next one, the leading coefficient is a negative. So I do want to make sure that I factor out that negative with it. I always want my leading coefficient to be positive, so we're going to always divide that out. So when I do that here and figure out what my greatest common factor is, so negative 5 will divide into all of them. And then as far as the m's go, m to the first is the smallest exponent that I have there. Right? So that is going to be my GCF. So I'm going to just change this here. So negative 5m is on the outside, and when I divide each part by negative 5m, all right, we'll see what we have remaining here. So here, the negative 5 divided by negative 5 is just a 1, and I'm left with m to the third, subtracting those exponents. 10 divided by 5 is 2, m to the third divided by m is m squared, and then negative 15 divided by 5, I should say, is negative 3, and the m's completely divide out. Now the thing about this, when I'm factoring, right, I can check my answer by multiplying back out, because we talked about earlier in this module how to multiply polynomials together, and now factoring is just undoing that process. So if I distributed that negative 5m to everything, I should come back with what I started out with. Okay, so just one way that you can do that. All right, and this one looks a little bit different when we're looking for a greatest common factor here, because our greatest common factor is actually going to be all of that is inside the parentheses, right? Because remember, terms are connected by add and subtract signs. So this is all one term, and this is another term. And so I'm trying to see what each term has in common, and what they have in common is that 2x minus 1. So I'm going to put that in one parenthesis. And then in the other parenthesis is going to be the leftover. So I'm just left with x here and minus 4 there. So in the other parenthesis, I'll have x minus 4. Okay, and if I was to FOIL this out, then I'd come back. Well, I guess it wouldn't look quite like this, because I'd have to distribute that through to see what it all looks like there. But so that's how you factor those type, which leads us into how to do this thing called factor by grouping. So on factor by grouping, you'll always use factor by grouping when there's 4 terms. Okay, so let's write that down somewhere here. Use with a 4-term polynomial. All right, so first thing we're always going to do whenever we're looking to factor anything is to look and see if there is a greatest common factor, like we just talked about on the other ones. And so as I look at each of these four terms, in this one I can see there's not something that will divide into all four of those terms. All right, this one doesn't have a number in it, and all of these do. And then this negative 12 doesn't have an x or a y in it, so we can't do that. So what we're going to do is we're going to split these in half. So the first two terms on one side, and then the second two terms on the other side. So we'll just kind of split it there. And now we're going to find the greatest common factor with these two terms. So if I look at that, the only thing that these two terms have in common is just y. And then my leftovers, when I factor out y, will be x squared minus 2. Okay, and then I'm going to do the same thing on that second one. What is the greatest common factor of both of those? Well, it looks like it's just going to be 6, and it's a positive 6. Let's make sure we put that down. And then when I factor it out, I'm left with x squared minus 2. And you should notice that these end up being the same thing, and they need to be the same thing in order for this factor by grouping to work. If they aren't the same, then you should probably look and see if you did something wrong, or if you need to rearrange your terms there. Sometimes that will help. So on this one, all right, so x squared minus 2 is our greatest common factor. It's what's in common with both of those terms. And then my leftovers are the y plus 6. And so that is my answer. And again, if I, FOIL that back out, if I multiply that all back together, I will get back to what I started with. Okay? So if you're ever in doubt, if you factored it right, just think about multiplying it through there. Okay? All right. I'm going to skip some of these and let you go back and fill some of those in, just to give you some practice, because I want to make sure that we get to talk about all the different types of factoring today that we need to. So the next type, we're talking about trinomials. So remember, trinomials, tri means 3, and nomial means term, so it has 3 terms. But our leading coefficient on these is going to be 1. And those are actually a lot easier to factor than, say, ones that don't have that. So let's take a look at this and see what we can do here. So we are asking ourselves some questions here. We want to know what multiplies to be 9 that adds to be 6. Right, so I'm looking at that. What multiplies to be 9 that adds to be 6. And so when I'm dealing with this has a leading coefficient of 1, right, there's no other number out in front of here, so that means it's a 1, I can go straight to my parentheses to do this factoring. So x times x gives me the x squared. And then, like I said, I'm thinking to myself, what times what is 9 that adds to be 6? Well, that will be a positive 3 and a positive 3. And I could write this as x plus 3 quantity squared, right? That whole thing squared. But on the homework, it will accept it either way, whether you leave it like this or like this. And same thing on the test. I'll accept it either way. Okay, so either of those answers are good. Okay, let's try this next one here then. Again, we're thinking what multiplies to be 8 that adds to be 6. So if you're not quite sure, like if you're thinking, okay, there's a few different things that I could come up with, you could list all the factors out to see what multiplies to be those numbers. And it's always a good idea to work organized. So if I'm thinking what times what is 8, I've got 1 times 8, and then 2 times 4, and 3 doesn't go into it evenly, and then I'm back to my 4. So these are the only possibilities that I have, and the only way to get a -6, add them to be a -6, is that both of these numbers are going to need to be negative. So this time when I write my answer out, right, so I'm going to have a -2 here and a -4 here. And remember, I'm getting the first part of it from this. What times what is x squared? And that would be x times x. Okay, and that is your answer. Okay, and again, you can multiply it out to check those. So use that as a strategy to help you make sure that you're understanding that. Okay, any questions so far on either factor by grouping, factor out the greatest common factor, or these trinomials so far? All right. Well, let's go to problem 11 next, because this one is going to be, and notice, I mean, it's giving you a hint here that we need to factor out the greatest common factor first. On the homework, it's not going to do that. You just need to remember that that's always, always, always the first thing you want to look for to see if there's a greatest common factor. All right, so yeah.
Sorry to interrupt you.
You're good.
When I was doing that game on factorization, there was one that I did not understand. I ended up going, okay, this is the way that it's supposed to be done. I'll do it that way. But can I give you that problem, and maybe you can tell me what I was doing wrong?
Yeah, I had one person tell me that there was one that was a mistake. So I wonder if the one that you're talking about, it wasn't, you know, she was doing it correct, but it was saying she wasn't correct. So I wonder if that was the case for you. What was the one that you were looking at?
X to the square plus 19x plus 88.
Okay. And so what did you think about that multiplied to be 88, that added to be 19?
It was 11 and 8. The answer that the system ended up taking, you know, after like 4 times I got it wrong. But also the signs did not make sense. There were, like I said, I do not know if this was the one that there was a mistake, that there was an error, or if it was me. Probably was me.
No, I mean, if this is what you came up with, x plus 11 times x plus 8, then it was the computer messing up. I am so sorry about that. Yeah, somebody else told me that happened to them too. So
good. I was like, where is the explanation? Because the computer would take minus 11x minus 8x, and that's why I couldn't put it together. So
yeah, that if it would be that if this was a negative in the middle, right? If both of those would have to be negative if that was negative. So yeah, you had it right. It should have been factored this way. Yeah. Okay, so let's take a look at this one now and see if we can figure out what our greatest common factor is. And doing this, I would always start with like the lowest number that you see there and see if that will divide into all of the terms. And on this one, it does. And so we know that 3 is going to be our greatest common factor. And so when I divide each part by 3, I'm left with x squared plus 4x and then minus 12. And then I'm not done. Now I need to factor this further. So now I'm thinking what multiplies to be negative 12 that adds to be 4. So things that multiply to be 12, 1 times 12, 2 times 6, 3 times 4. And I can tell that I have all of the possibilities because I worked organized, right? I did 1 times something, 2 times something, 3 times something, and then there's no numbers between 3 and 4. So I know I have all of them there. So if I'm looking to see how could I add or subtract these numbers to end up with a positive 4, this is going to be our winning combination, but on it, I'm going to have a positive 6 and a negative 2. All right, 6 minus 2 gives me a positive 4. So in my parentheses, I'll have x minus 2 and x plus 6. And then that whole thing would be your answer. So be really careful. Make sure you don't leave off that greatest common factor in your answer. That oftentimes is where people will make some mistakes on that. Okay. All right. Well, we're going to move into talking about how to factor. And I'll let you, this is kind of talking about a system that I'm going to be using here to help us when our leading coefficient is not 1. Okay, so that's what I'm going to kind of look at here. This is not 1. So the way I go about this, I can't just say what multiplies to be negative 9 that adds to be 3, because that's leaving this 2 out completely. And so really what we're doing up here, and we don't really say it, is we're thinking, let's see, let me go up to the one above here. All right, so on this one say, there's a 1 here, and so I'm really thinking 1 times 8, what multiplies to be 8, and I'm getting that from this 1 times 8. All right, but since it's a 1, it's not going to change it, and that's why we're just looking at that third term. However, on these, when our leading term isn't a 1, we need to make sure that we take that into account. And we call this the AC method because when we write out a quadratic, it's in this form, ax squared plus bx plus c. And so notice how we're taking that leading coefficient and then that constant term, which we call a and c, and we're multiplying those together. Okay, so that's the first thing that I want to do. So 2 times negative 9 is going to give me negative 18. So I'm thinking, what multiplies to be negative 18 that adds to be just what we have in the middle again, that adds to be 3. And so I need to kind of think about all the different possibilities that I have there. So always start off with, what multiplies to be that number. And usually when it's a negative number, I come back to that negative later, and I just start thinking about what multiplies to be 18. So I know there's 1 times 18, there's 2 times 9, there's 3 times 6, and then I want to keep going and see, does 4 divide into it evenly? Because that would be the next one, and it doesn't. And then 5 would be the next one, and that doesn't divide into 18 evenly. And we're back to 6. So I know I have all of them here. So work organized, because when you get like a number that has a lot of different factors, it's going to be really helpful to make sure you stay organized when you're doing this. And then the only way that I can end up with adding to be a positive 3, so it looks like it's going to be this, right, is my combination. But since I'm multiplying to be a negative 18, one of them has to be positive and one has to be negative. And so in order for there to be a positive 3 in the middle, I need the bigger number to be positive. So my smaller number, my 3, is going to be negative. All right, so negative 3 times 6 gives me negative 18. Negative 3 plus 6 gives me positive 3. Okay, so the most common mistake that I see people make on this is they try and write out their answer as x minus 3 times x plus 6. All right, just like doing what we did before. But that's not going to work, because if I try and FOIL this out, I'm not going to come back to what I started with here. I can even tell on the first thing that I multiply together, x times x is x squared, not 2x squared. And so that means this cannot be what I want to do. Okay, so just caution you, don't take those terms on this and just put it into those parentheses. We're going to have to do something else first. So we're going to take that first term and leave it just how it is, so that 2x squared. And then the middle term, I'm actually going to write as two terms. So, and I'm going to change it so that the negative 3 and 6 are in here. So I'm going to have a negative 3x plus a 6x, right? And again, let's look at that again. Negative 3x plus 6x does give me that positive 3x that I need there in the middle, so that's good. And then the last thing I need to do is bring down that minus 9. And now I have a 4-term polynomial. And just like I said above, when I have a 4-term polynomial, I want to think factor by grouping. So I'm going to divide this in half and then find my greatest common factor on both of the parts. So on this first part, if I look for my greatest common factor, well, 2 and 3 don't have a common factor, but there's an x that both of them have in common, so x is going to come out, and that's going to leave me with 2x minus 3. Okay, keeping in mind, I'm dividing each of these parts by the x like I did before. Okay, now I need to do that second half of it. So on the second half, I've got 6x and negative 9, and I can see that 3 will divide into both of those. So plus 3, and then left over is going to be 2x minus 3. And again, I can see, oh good, these are the same, right? I said these have to be the same, and so they are the same, so that goes in one parenthesis, and then my leftovers go in the other parenthesis. And now this time, if I was to FOIL this out, I would come back up with what I started with. Okay, so just be really careful. Make sure you don't forget to take these steps in here. Okay, and there's another method that we can do, and so I'm going to skip down here to number 15 and just show this method that we call the box method. So if you remember back to when we were multiplying polynomials, we multiplied them through, and then we saw, what they had in common, multiplied them together, and then we could add our common terms together. But now we're going to undo that process. So I'm going to start it out just like I did this one. So meaning I need to look and see, again, I've got to multiply the a and the c together. So I'm doing 4 times negative 6. So I'm trying to think what multiplies to be negative 24, right? Because 4 times negative 6 is negative 24. That adds to be that middle term, which is negative 5. Right? And so then I need to figure out what my possibilities are here and find that winning combination. So there's a few possibilities that we have here with 24. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And then the only number between 4 and 6 is 5, and 5 doesn't divide into it evenly. So I know one of these combinations is going to be my combination that will add to be a negative 5 is what I'm looking for. So maybe let's start by looking at 3 and 8 here. So is there a way that I could add or subtract them so that they would end up with a negative 5? Sure, if I have 3 plus a negative 8, that would give me the negative 5 that I'm looking for. All right, so those are my winning combination. That's what I want to use. And if I wrote this down as a 4-term polynomial, again, bring that first term down just like it is, change the middle term to be plus 3x minus 8x, and then bring down that last term with it. Okay, and then you could go ahead and figure it out like we did up here, but we could also put our terms up in here. So I'm going to try and follow the colors that are here. So if I have so this time I'm putting my numbers inside here. Actually, let me go to this. So I'm going to have 4x squared, and then 3x, so I'm just putting one of these in each of the boxes, negative 8x, and then negative 6. And these other like little ovals are to help me kind of figure out what the common factors are in them. And by the way, it doesn't matter. Sometimes people write this down and they put here like as negative 8x plus 3x. It doesn't matter which way you write those, and it doesn't matter which one of those boxes it goes in. It'll work out. Okay, so now instead of doing our factor by grouping that we did up here, we're just going to factor out greatest common factors in our columns and our rows. So notice this oval, right, with the blue around it. So I'm looking at 4x squared and negative 8x. Well, I can see that 4 will divide into both of those, and also x will divide into that. Okay, so 4x is part of my, is going to be part of my answer here. Now let's go to this next one, which is kind of like a light orange color. 3x and negative 6, well, their common term would be a 3. Right, so I'm not worried about what my leftovers are, just what is in common with both of them. And then across, so my top row, where it's circled in red, right, what do these guys have in common? Well, it looks like just an x is what they would have in common. And then going to that last oval on the bottom, negative 8x and negative 6, since both of them are negative, I am going to factor out a negative this time. And 2 is the largest number that can go into both, so it's going to be negative 2. So when I write my answers, this is going to be one of my parentheses, and then this is going to be my other one. Okay, so let me write it out over here so we can see. So my answer is going to be, I've got 4x plus 3 in one parenthesis, and then x minus 2 in my other parenthesis. And then that would be my factored answer. So when you think about factoring, factoring means that it needs to be connected by multiplication. Right? If I say, something like 3 times 6, right, these are being multiplied together, so each of these are the factors. The answer to that is called the product, right? But we're looking to factor it, so we want to get it connected by multiplication is basically our goal when we're trying to do this factoring. Okay? Questions on those? All right. I'm going to skip over some of this. There's a lot of stuff in the book and a lot of videos and stuff you can watch. So if you're looking at some of this going, oh, I need some more practice on that, you'll find some practice and with the homework. Okay, so this next thing is called perfect square trinomials. And a perfect square trinomial is a trinomial that can be written as the square of a binomial. So notice how this is a plus b all squared, right? Or a minus b all squared. That's how those things are going to be factored, is kind of like this. All right, and so there's a couple of different ways like that you can tell. So in this first one, I'm asking you, is this a perfect square trinomial? So first thing that we want to do here is think about something all squared that gives us 49z squared. Well, if I do 7z times 7z, that's going to give me 49z squared. And then on this last term, the 1, if I take 1 and I square it, I get 1. Okay? And so when I do that, this becomes like my a. I'm just going to put these with some different colors here. Let's see, so there's B, and then A is going to be this one, all right? And so now I'm looking at it to see, is this a perfect square trinomial or not? So what I'd have to do, because notice the middle term right here is a negative 2ab. Well, if this is my a and this is my b, and I multiply them together, 7z times 1 is 7z, and then multiplying it by a 2 is going to give me that negative 14 in the middle. So this is a perfect square trinomial. And so we can factor it in this way. And the way that we would factor it is we just have, since it was connected by a minus sign inside here, then it means it's going to have that minus sign there also. So I'm going to have in my parentheses, my a is 7z, and my b is 1, but again, I need to make sure that I do the minus 1, and then that's going to be all squared for my answer. Okay. Or if you wrote it at 7z minus 1 times 7z minus 1, I would be totally fine with that as well. Okay, that means the same thing. These are the same. Okay, so that is how we deal with these perfect square trinomials. But really, I mean, sometimes students don't necessarily, memorize this or anything, because this is still a trinomial, and so you still could do it the same way that we did the ones above. So kind of keep that in mind too. All right, let's look at this next one here. Notice that my first term is a perfect square and my last term is a perfect square. And by perfect squares, I mean if you have a number all squared. So let me list some of them out here. So 1 squared is 1, so 1 is a perfect square. 2 squared is 4. 3 squared is 9. 4 squared is 16. And so on. You should have memorized up through 12 squared is 144. Okay? And so I can see that, yeah, these are the first and last terms are perfect squares. So it's a pretty good bet that this is going to be a perfect square trinomial, but not always. So be careful with that. Okay, so I'm thinking, what all squared gives me 9a squared? Well, that would be 3a. 3a times 3a is 9a squared. What times what gives me 64? Well, that would be 8. And so, again, I'm going to call this my a and this my b. All right, and if I'm using this time, notice my middle term is positive, so I'm going to be, and this is positive, so I have a positive there in the middle. So when I write this out, I'm going to have, let's see, put this like this, all squared. So my a term is 3a, and then my b is going to be a plus b. So 3a plus b, or sorry, plus 8. The b on this is 8. All right, and so that would be my answer. Okay. Perfect squares are also going to come into play on something called a difference of squares. So notice this time we've got only 2 factors, we only have binomials instead of trinomials. They only have 2 terms. And so that's a good indication that it could be a difference of squares if there's only 2 terms. Not always, but that could be the case. All right, so if we're trying to factor this, and again, we could think of it like this. I could think of this equation, this expression as x squared plus 0x, because notice there's no x term there in the middle, minus 4. And doing that, then I could just go back and think about what I did before when the leading coefficient was 1 with a trinomial. I thought, what times what is x squared? Well, that will be x times x. What times what is negative 4 that adds to be 0? Well, I'd have to have a positive 2 and a negative 2. If I multiply those together, I get negative 4. If I add them, I get 0. And so that's how these factor. Okay? And you can kind of see down here. So if I have something squared minus something squared, it's going to factor to be that a plus b times a minus b, which is what happened here. Okay? Now, on this one, we don't have a leading coefficient of 1, so let's do kind of what we did up here and figure out what those a's and b's are going to be. So again, I'm just trying to think of what all squared is going to give me, let's see, what all squared is going to give me 16x squared. Well, 4x times 4x gives me 16x squared, and then 3 times 3 gives me 9. Right? And so then again, if I know this is my A and this is my B, right, this time I'm going to do A plus B times A minus B. So in one parenthesis, I'll have 4x plus 3, and in the other parenthesis, I'll have 4x minus 3. And then again, if I multiply that all together, if I FOIL it, I'll come back with what I started with there. And so that's always a good check there to do. Okay, the other thing that I want to point out on here is that we can't factor the sum of squares. So we could factor it when it was x squared minus 4 up here, like in problem 19, but down here, where it's x squared plus 4, that doesn't factor. Even if we try to think about it, like what multiplies to be 4 that adds to be 0, well, we could do 2 times 2, but if I'm thinking of, doing this, I'm like, well, to be a positive 4, both of these have to be positive. But if they're both positive, I'm going to end up with an x term, right? I get 2x here and another 2x here. So I'd end up with a 4x in the middle there. And then people are like, well, change one of them to a negative. So I do that, but then negative 2 times positive 2 gives me a negative 4, not a positive 4. Okay, so there is no way to factor these. So just watch it closely on there. If it's something squared plus something squared, then it's not going to factor. So our answer on this is that it's not factorable, but on the homework it might say something like D and E or something. Like you can't do it. Okay? All right. Questions there? Those? It took me a while to get through all of those different types of factoring, but there's so many different types that you need to make sure that you know. And so that's why I've given you a few different options there of things that you can, like little games and stuff that you can do to really help you hone in on this factoring skill, because it is so important. Okay.
Mm-hmm.
Was there a question?
No, I just said okay.
Yeah. Yeah, it's good. All right. Now, there is a Desmos activity that you can go in and complete on there. So if you want to, it's always going to be that same class code. And so I gave you the class code before. But this time, it's going to be talking about graphing quadratics in general form. And it's kind of nice because it gives you can kind of play around a little bit with it and see what's happening. So think about doing that. Okay. Now, we'll do a couple of different things here. So when we have something in this general form, right, we can't tell the vertex very easily, right? Because we talked about vertex form before, and that was really helpful, right? That's right here, the vertex form. And then we also talked about intercept form, and intercept form was nice because we were able to find the x-intercepts easily. Vertex form, we were able to find the vertex easily. But when it's in general form, the one thing that we can find out easily is the y-intercept. Okay, let's notice down here where I say the c value, let me do this in a different color here, the c value, all right, determines the y-intercept. So whatever this number is right here is going to be our y-intercept. Okay, so that's the reason why we like this form, is because it can tell us that y-intercept easily. Now the a value, just like we talked about before in vertex form and intercept form, it did have the a in front of it here, and those same a's do the same thing, where it makes your parabola either right side up, upside down. It makes it either skinnier or wider. Okay? Same things that we've talked about before with it. It still applies there. And then b is kind of a strange little thing, but it changes how steep the parabola is at the y-intercept. And so if b is positive, like we have here, the slope of the parabola at that y-intercept is going to be increasing. So as you look at the parabola from left to right, it's going up. And if b is negative, that means it's decreasing. It looks like as you're looking at it from left to right, it's going down. Okay, and you'll talk more about that b value and stuff in 1050. We don't get too much of it into it in 1010, but just understanding kind of what it is. Now, we've talked about how the vertex is a really important part of a parabola. So we've got to have a way, when it's in general form, to be able to find the vertex. And so there is a little formula here that you're going to be using. And so basically, so this is my x and y coordinate. I don't know if you can tell, that's kind of what it's trying to show here. And so to find my x value, I'm going to do negative b over 2a. And remember, the a, b, and c that I talk about in these are coming from the coefficients in there. All right, so I'm doing opposite of whatever that middle number is divided by 2 times that first number. And then once I get that x value, all I'm going to do is I'm going to plug it back in where I see my x's here. And remember, f of x is the same thing as y, so when I do that, I'll get my y coordinate of my vertex. Okay? All right, so let's try one, and we'll talk more about that as we go through it. Okay, so here's my trinomial this time, and it's in general form, and I want to find the vertex, and then I'm going to change it to vertex form. Okay, so let's first of all identify the coefficients. So my a is going to be 2, my b is negative 8, and my c is 7. And then finding the vertex, I'm going to use that formula, x equals negative b over 2a. And in the book, it kind of shows you where that kind of comes from. And we'll see it more in Module 6. And we can kind of see like why this is this, why it's this formula. Okay. But let's go ahead and put this in here. So x equals negative b, or the opposite of b. So I need to do positive 8. Over 2 times a, and my a on this is 2. So I get 8 over 4, which is 2. Okay, so I've got part of my vertex. My x coordinate is 2. And then to find my y, I just need to plug that 2 everywhere I see x in my equation. Okay, so I'm going to have y equals, f of x is the same thing as y, 2 times, and in place of x, I'm going to put 2 squared, minus 8 times x again, which is 2, and then plus 7. Now we just need to go ahead and simplify this using order of operations. So 2 squared, got to do that first, is 4, times 2 is 8. And then negative 8 times 2 is negative 16. And then plus 7. Right? And so when I combine those all together, I end up with negative 1. So that is my vertex. Okay? And then it says it wants me to write it in vertex form. So remember, my vertex form was like this. Got a times x minus h all squared plus k. And so even though this is like an x and y coordinate, specifically when it's a vertex, we call it h and k. And so that's what I'm going to be putting in place of my two things here. And on my a, that's just coming from whatever my a was here, which we said is 2. Okay, so I'll have y equals, place of a, I'm going to put 2, times x minus h, so minus 2, all squared, and then plus k, my k is a negative 1, so I'll put minus 1. And so now that is in vertex form. Okay. All right, questions on that? How to find that vertex? And how to write it in vertex form after I've found my vertex?
No.
Okay. All right, well, let's skip down here to problem 3 because I want to make sure we talk about how to find the different parts of this and graph it, because on the homework it's going to have a lot of these types of problems. Okay, so on this, to find the x-intercepts, we need to factor this. So that's the whole reason why we needed to do all of that factoring before. I've got to get this in factored form, so it's in that intercept form, so I can do that. So when I am factoring this, let's take that, well, I'll just factor it here. Notice that the leading coefficient is negative 1, and so I'm going to start by taking out that greatest common factor of negative 1. And when I do that, when I factor that out, I'm left with x squared plus 8x plus 15. And now I just need to figure out how to factor that. All right, so this factors, and I still have that negative 1 in front, and I'm going to let y be 0, which again is that h of x part. Right? Because when I'm finding my x-intercepts, I let y be 0, and then I'm going to solve for x. So let me just write this all over here again. All right, so now I need to think, how does this factor? So the leading coefficient is 1, so I can go straight to my parentheses. So I'm thinking, what times what is 15 that adds to be 8? Well, 3 times 5 is 15, and if both of those are positive, it'll add to be 8. So I'll have x plus 3 times x plus 5. And then now we're going to need to use that zero product property where we set each part equal to 0 and solve. So I'm going to take that. If I do the 0 equals negative 1, remember there's no x to solve for there, so I don't really need to do that part. So I'll start with my x plus 3 equals 0, and then I'll go to my x plus 5 equals 0 and solve each of these. So when I subtract that over, I get x equals negative 3. Subtract that one over, I get x equals negative 5. And then I always want you to write these answers as ordered pairs. All right, so let's practice writing this down as an ordered pair. So x is negative 3 and x is negative 5. And remember, we put 0 in place of our y. So zeros are here. Okay, so I found 2 points on the graph so far. All right, now the axis of symmetry, kind of like we talked about before, it's always going to be halfway in between our x-intercepts. So that means we need to find the average of those two. So I'm going to take that negative 3 and add it to that negative 5 and divide it by 2. Right? An average is you add them together and divide by how many there are. So I've got negative 8 over 2, which is negative 4. All right, and this is the x. It's a vertical line, and so don't just put negative 4 as your answer. You need to write it as an equation. X equals negative 4 will be my axis of symmetry. All right, and the vertex, you could go about finding this a couple of different ways. You could just go ahead and do like we did before. Remember that we said once we know that axis of symmetry, x equals negative 4, well, my x-coordinate of my vertex has to be negative 4 because this axis of symmetry goes right through that point, whatever the vertex is. Okay, so I could do that, or I could use that x equals negative b over 2a, like I was doing above, using that formula to do it. Okay, but if I just use this, I need to go back to the original here. All right, let me circle it again in a different color. All right, so all the way back up here with that negative out in front and everything. Okay, make sure you're using that whole thing. So I'll have y equals that negative, and then inside the x, so when I take out the x, I'll put the number in parentheses, which is negative 4, and then I need to square it, and then minus 8 times negative 4, and then minus 15. And then I just need to simplify this. Again, be careful with your order of operations. Negative 4 squared is positive 16, times by a negative is going to be negative 16. Okay, and then here I'm going to have plus 32, and then minus 15. And so then when I combine these all together, I'm going to end up with a negative 1. Right, let's see. Oh, actually a positive 1, right? Because I've got negative 16 plus 15 will give me a negative 31. So actually I'm going to end up with a positive 1 there. Okay, and so there is my vertex. All right, and then the y-intercepts, we let x be 0 and solve for y. So let's do that. So again, going back to our original equation here, all right, we're going to put 0 in place of x. So negative, and then 0 inside squared, minus 8 times 0, minus 15. So, and I said this earlier, but I wanted to work it out here so you could kind of see. But here I have 0 squared, 0. So there's no more term there. Negative 8 times 0 is 0. So all I'm left with is negative 15. And so remember I said that this value right here is always going to be our y-intercept. Okay? But again, write that answer as an ordered pair. So we let x be 0, so we'll have 0, comma, negative 15. And now we have all these different points that we can use to graph it. So let's see, negative 3 and negative 5 were my x-intercepts. Let me put these on here. So negative 3 and negative 5. Okay. And then negative 4 was my axis of symmetry. So that's going to be right through here. My vertex is negative 4, positive 1. So over 4, up 1. All right, so if that's my vertex, that means it's my turnaround point. So I can see that I am going to have an upside down parabola. And if I go back up to my original equation again, remember I have this negative out in front, and that's telling me it is going to be upside down. So it looks like we're on a good track here. And then the other thing that I can see is I have my y-intercept is 0, negative 15. So that would be here. And because of that axis of symmetry, I also can see that there's going to be one over here, right? If I think about, well, how far away is this? Well, it's 4 places on the right of it. So if I go 4 places to the left and then down to the 15, let's see, all right, can't quite tell if I'm off a little, whoops. Right, and so then I'm going to have my graph looking something like this, an upside down parabola. Whew, just wish those would look better, but anyway, so that is what you're going to be doing a lot of on it. So I would say, come back and, rewatch this if you're, struggling to figure out how to find any of these parts of the parabola and then graph them. Okay. And then there is going to be some story problems, and so I'll look at this first story problem because this really encompasses everything that they're going to be asking you in the story problems. So a small toy rocket is launched from 44-foot pedestal. H is the height in feet, T is the time in seconds after taking off, right? So they give you this equation. You don't need to go and, write an equation or anything. It's going to be given to you. All right, so now it's asking how long will it take the rocket to hit the ground? Okay, so let me draw a little picture of what's going on here. It says, let's see, that couldn't, 44-foot pedestal. All right, so that means it's going to be up on a little pedestal like this. The rocket is taking off, and then at some point it's going to hit the ground. Okay, and so this, we'll say that this part right here is the ground. And so that means my height is 0. So it doesn't give you that the height is 0. But when it tells you how long will it take to hit the ground, that is telling you that you're trying to figure out when the height is 0. Okay, let me try and write that again. All right, so that means in here, so my h of t, so I'm going to put 0 equals the rest of this, right? So negative 2t squared plus 7t plus 8. And now I need to factor this like I was doing before. So you're going to see that factoring is going to come in everywhere. And so we need to figure out what multiplies to be negative 8. I've got to multiply those two together, right? So what multiplies to be negative 8 that adds to be 7. And so when I do this, it looks like it's going to be 8 times 1, right, is what it's going to be multiplied to be. But then in order for it to be a negative 8 and a positive 7, I'm going to need my 1 to be negative. Okay, so just write that like that. So when I write this out, I'm going to do my 4-term polynomial, so 2t squared. And then my 7t I'm going to write as plus 8t minus 1t. And then bring down that last term, that plus 4. From here you could do the box method like I was showing you above, or you could just do the factor by grouping now that we have these 4 terms. And I'm going to do it this way just because of this negative here. I want to show you what we need to do with that because we didn't have one pop up before like this. So on this, notice my leading coefficient is negative, so I want to factor that negative out with it. Okay, so I've got a negative 2t is going to come out, leaving me with t and then minus 4. All right, because when I take 8t and divide it by negative 2t, left with a -4. Okay, and then on this one, again, like this third term here kind of is like a whole different animal. So again, since it is negative, we're going to factor out that -1, and then left is going to be t minus 4. Okay, that's still 0 equals all of this. All right, so now I can finally get it to the factored form. T minus 4 is in one parenthesis, and -2t minus 1 is another one. And we could have started off by just factoring that -1 out of everything from the start, and that could have helped us to make sure that we didn't make any mistakes with negatives here. And then we just need to set both of those equal to 0 and solve. So here, t is going to be 4, and then on this one, I get, well, let me show you, because I'll have -2t, equals +1. I'm going to add that over and then divide by -2. So I'm just trying to show you that this ends up being a negative answer, and time can't be negative. So we throw out this solution. It's an extraneous solution that won't work because time can never be negative. So that means our answer is t equals 4, or specifically 4 seconds is how long it's going to take for it to hit the ground. Okay, so that one takes longer than these other two. These other two are a little bit faster. So here it says, when will the rocket reach maximum height? Right, so we're trying to figure out, okay, when will it reach that maximum height? And then what is the maximum height of the rocket? So here we want to know the time, and then here we want to know what that height is. So we're going to use that vertex formula, because that is the part of the parabola that I'm looking for. All right, that is going to be a maximum where that vertex is. So let's do that. So we have our x equals -b over 2a. Well, -b would be -7 over 2 times -2. So it gives me -7 over -4, or that's going to be 7/4. And then I'll need to use that to put it back into the, but looking at, I guess, 7/4, sometimes people are like, well, that doesn't really make sense to my brain, 7/4 of a second, So really, if you wanted to change that, you do 7 divided by 4. That is 1.75. And so if you want to change it to that decimal, that's fine. But make sure on the homework you look to see if it's okay if you change it to that decimal. And then you're just going to plug that in. Remember, this is what x was. So 1.75 seconds is how long it's going to take to get to that height, right? So it started here. To get up here, it's going to take 1.75 seconds. And then now we need to figure out what is the height of that. And so let's plug that in. So we've got -2 times 1.75 all squared plus 7 times 1.75 and then plus 4. And I don't mind, like, on your, like tests and everything like that, like, I don't want you to just have an answer, but if you will show me how you're getting that, because I know a lot of your calculators, you can just put this whole thing in and it will come out with the answer that you want there. Let me see. Oops. Trying to figure out what this is really quick. Did any of you get it? see. I don't have my good calculator right here beside me, so let's see, so this part should be negative 6.125. And then if I do 7 times that, that's going to give me 12.25, and then plus 4. All right. And I can see that this was kind of messed up from the start. I wonder if I wrote this down wrong, because if it says it's launched from a 44-foot pedestal, this should be 44 right here, and it's only listed as 4. Because when I'm coming up with my answer, I'm coming up with 10.125, which doesn't make sense because it's saying that this was a 44-foot pedestal, but really, according to this, it was only a 4-foot pedestal from what my equation said. So it does make sense, if that was only a 4-foot pedestal, that the maximum height is going to be 10.125 feet. And a lot of times on this, they'll come out to be whole number answers, so you won't have to deal with decimals or fractions on it. Okay, so those are the 3 things to make sure you know how to do. So when will it hit the ground? That means you need to set it equal to 0, factor and solve it. And then when you're talking about maximum height, you're talking about finding the vertex. So use that vertex formula to figure out what x is. When you find out what x is, plug it back into the equation, or I guess on this one it was really t, not x. You plug that back into the equation, and then that will give you how high it goes. Okay? All right, so I think we're going to stop there, but please feel free to reach out to me when you have any questions. If you have some questions that you want to ask me about right now, that's fine as well.